Hey, what's up, folks? How's it going? And Today we are going to look into the Git interview notes, first part one, where we'll just go through the complete flow so that we understand what are the comments are used and why they are used and under which scenarios they're used. Okay. So before I start with that, we'll just have a quick look at summary table. What are the concepts we are going to cover? So core concepts will be Git versus SVN, working directory, staging, repo, commit, those kind of thing. An example question like Git pull versus Git fetch, what is detach head. So these are the core concepts. Then essential commands like clone, pull, fetch, push, merge, rebase, reset, revert, status, diff, and log. And there may be question difference between Git merge and Git rebase. Third one is branching and workflow. So how the branch operation happens, Git flow, GitHub flow, trunk-based flow, fast-forward merges, those kind of concepts. And there are some advanced concepts like cherry pick, squashing, that also we'll discuss. There are some other concepts we'll be covering that. And if you get time, you can go through that. But these are the basic concepts you should go through. GitHub and collaboration, for branch, clone, peer, for review. These are also important concepts. A difference between fork and branch. After that, we'll cover security compliance, Githook. Githook will be covering again in CI/CD part, but here also we'll be covering Githook, file management, cleanup and maintenance, history inspection, GitOps, productivity, and troubleshooting. So interview preparation metrics, what are the most important thing? Four commons, pull versus page, merge versus rebase, reset versus revert, branching, conflict resolution, stashing. So these concepts are required for all DevOps tools. High priority, cherry pick, squashing, reflog, tag, soup, PR workflow, crunch protection, GitHub action basics. They are also equally important for the mid to senior DevOps. There are other concepts, submodules, etc. Object model workflow. These are for mostly senior roles. Won't be covering that much. Like it will be there in the notes, but we'll be focusing mostly in the first two parts. And then a scenario complexity level, basic level is like single step recovery, simple conflicts, like undo, unpush commit, resolve simple merge conflict. There are some basic scenarios, intermediate scenarios are there. And this is like common interview question patterns. Generally, in the interview they ask what is the difference between X and Y? Like what is the difference between git pull versus page, merge versus rebase, reset versus revert? Or how do you revert it post commit? Or how do you resolve conflict? Or when would you use cherry picker? Right? Or explain the concept of detached head, or you accidentally committed secrets into the repo, and how will you remove that? Or how would you design or implement GitOps branching study? So there are different patterns. What are the pros and cons of something? Multi-repo, mono-repo, etc. So there are some of the patterns. So for entry level, focus will be on core concept, essential commands, basic branching, simple conflict resolution, PR workflow. And common like commands, hands-on commands, simple merge conflict, basic GitHub actions. For mid-level 2 to 5 years, Git workflows, advanced operation, hook, branch protection, CI/CD integration. These are important and scenario-based problems. Okay, now I will start with a real-world example where two developers and DevOps they are working together. And project name is movie booking application, where it's a microservice application with backend, frontend, and DevOps team. So project structure is like this. But in reality, there may be 100 other files. But to keep it simple, we have backend. Backend have few Python files, app.py, payment.py, user.py. Then we have the front end. So front end is the UI part. Back end is your API which interacts with the database, etc. And then we have the infrastructure where the DevOps guy, right? Kubernetes deployment, Terraform, CloudFormation, Dockerfile, configurations, all these things he stores in this infrastructure as a code. So the other three different folders. An application is a mobile booking app. So first step will be like repository setup and foundation. So when the project is initially started, developer might have developed some very basic Hello World kind of application or basic skeleton, just created the structure of that project. So as a DevOps, you will go and go to repository section and create a new repo. Okay, so you will create a new repo from here. You can create a new repository. Go to repositories and you can create a new repo. Then you can create a new repo. So once you create the new repo, movie booking app, then uh, you clone it. So you will git clone and you will get that URL from here and you will clone it. And assume that you have configured all the login details and you have configured your machine also with the credentials, etc., so that you can clone it because it may not be the public repo. And after that, what you can do git remote -v. So you can see that what is the origin server, means what is the remote server details. And then you need to understand what is working directory. Working directory or current directory where you have the actual files. And developer has some basic files, basic skeleton structure that he will keep it there. And then some files he will be pushed for next commit. That will be in the staging area. So he will do git add and that file name. So that will be in the staging area. So it's ready to commit into the local repo, and finally it will be pushed to the remote repo. .git directory is the local repo with full history. Then we have the remote repo, GitHub or GitLab. So this is the remote repo. Once you push it, it will be available. You'll be able to view the code here. Okay, and after that you will create a git ignore. Some files you don't want to push it to your repo. For example, PYC files, PyCache files, environment files, VNV, virtual environment, backend side, front-end side, build, distribution, .dstore. .dstore is Mac file, Macintosh machine. This file gets created. You don't want to push it to your repo, so you will be putting them into git ignore file, and you add git ignore and commit that. Add git ignore for Python and Node, and then push it. And once you push it, you will be able to see it on your GitHub project, GitHub repo. After that, you will want to DevOps will set up branch protection on GitHub. So you need to protect the main branch. So you have generally like main branch should be safe. Randomly, somebody should not push code which is not reviewed or which has a lot of bugs or which is it should not break the main branch, right? It should be protected. So what you will do, like you will the DevOps will go to settings and then go to branches and then branch protection rule. You will add rules. Okay. And here you will set up some rules that require a pull request before merging. So, or you will set up a couple of rules to protect the branch so that nobody can push it directly. So main branch is now protected, nobody can push directly. So if someone want to push code, he has to create a PR request, pull request, and then once it's reviewed, it will be merged. So that's why this will be checked. You get a pull request before merging. typical approval, how many approvals? Two approvals maybe. There are multiple settings you can set. Required status, text to person, scanning results, code quality results. You can add many conditions that we can create your main branch. This is the DevOps job. We will do that, and after that, daily developer workflow feature branch model. So backend developer Rahul started working on the user authentication on the backend side. And so what he will do, he will switch to main and then pull that code, and then he will create a feature branch. For example, here you can see that some feature branch is there. Main branch is there, and we have a feature branch is also there. Yeah, div underscore branch. So you can create many other branches, and so this guy will start working on his own branch, user authentication, and he will start working on that. He will add some new code. He will try out something and maybe run some test and check the current status, what is modified or not modified. Then he will take a diff, what change, what not change. Then he will stage once he is added. Once he has added some code, he will stage specific file git add backend users.py. So he wants to commit it now, and then he can view the staged changes. So what are the changes there? He can see and then commit with descriptive message. He will commit it, then push it to the branch. Once that he push it, it will be if you go to this branch, you'll be able to see the latest code. Go to this his feature branch, and then I will keep on adding new features and keep pushing. And then the front end developer also started working. His renewal started working on the profile screen. He will add a profile user profile UI, and a similar command you will be executing git status, make changes to multiple files. What are the files modified? Stage all the modified files. Git add front end, app.js, profile.js, or add stage everything. Git add dot. So you can stage everything, or one by one, maybe 4 5 files here modified. You will just stage them. After that, you will commit it. That add user profile screen with avatar upload. So he added that feature, and he will commit to his local repo. After that, he will push it, and once he pushes it, it will be like you will see one more new branch, feature underscore user profile UI, user profile UI, and it is available. And you will be able to see the code from GitHub UI, GitHub dashboard also. Then finally, any other developer, he can come and he can check the commit logs, git log one line graph, decorate all, he will be able to see commit logs. Then DevOps guy also can check what specific author has committed, what Rahul has committed, or what was committed in the last 7 days, or what auth functionality is committed, such commit by message. So they are the different log functions. Right? Since 7 days, author by author name. So import and then show details of specific commit. Using commit number also can show the details. And then never push directly to main, always use feature branches. So push to your feature branches always, but don't push directly to main. Main should be always stable. Then there will be branching strategy like create branch for parallel work. So you are working on user authentication, another developer working on maybe payment, another developer working on SMS feature. So they will create different branches and they will start working on parallel. And as and when they develop feature, they will push it to their feature branch. And once they're happy, then they are going to merge it. And you can view all branches, Git branch. If you want to, this is Git branch for local branch on your local repo. But if you want to view the branches on the remote repo, Local repo you may have created 2, 3 branches. You have not pushed, so it's not there in the remote repo. So if you want to see remote repo, then you can git branch minus R. If you want to see all of them, git branch minus A, all branches, your local plus remote. And you can delete the branch after merge. Minus D, it's a safe delete. Means suppose you have not merged your branch, then it will throw error. Minus D means forcefully. Even if you have not merged, it's minus D deleted, gone. Right? And delete remote branch. It will delete from local. And remote you have already pushed. So remote branch also you want to delete. So let's discuss some best practices. When you create a new feature, you give branch name like this, feature slash selection. When you're fixing you're doing bug fix for payment, you will give this kind of name, bug fix slash payment return. This will be a branch name. Let's say you have found some issue on the production and you want to immediately, you need to, let's say you have to provide a hot fix. You have to push the fix within 1 or 2 hours. So you will be creating a branch like this, hotfix slash critical security patch. DevOps guy may keep branch name like this, infra slash skate update. And then syncing with the team. So you're working, but you have to sync with your team also. You're working on your branch. You have taken the code from main branch and you are working on that. You are adding feature. But someone else also, your colleague also has taken clone that main branch and created a new branch, and then he's also adding new feature and he's pushing it. So those changes also you need to like sync. So for that, what you will do git fetch origin. So download remote changes, and it won't be merging. You will be able to see what are the changes are there, and you can do git log origin main. You will be able to see what are the changes are there, and then you decide whether you want to merge it or not. Or if you want to merge it, you can say git pull origin main. So whatever are there, it will be merged to your feature bunch. And there may be some merge conflict when you because your friend might have changed something, your colleague, and he may have changed the function name, and you are working on that old function, you are modifying the function body. So function name got changed, there will be conflict. So you have to do some you have to do conflict resolution, and after that push it. So once you take the changes and merge it to your local branch, local feature branch, you want to merge it. That time you need to run it and see whether it's really working fine or not. In C program, you will be compiling it. You should not get compilation error before you push it. So what happens you can do manually, but better way of doing is to do through automation. We use hook. So there are the ways you sync up. You switch to your selection UI branch, then fetch origin. Then if there are some new changes are there, you want those changes to be also in your feature branch. So you will do rebase. Keep your branch up to date. You will be doing rebase. And before you push, you need to do some pre-commit, pre-hook, pre-push hook. Basically, run some local test. Pre-commit hook means before you do commit, you will do linting. Linting means it will find potential errors, bugs, stylistic issue, or suspicious construct without running the program. Without running the program, it will see, it will be running linter. It will see whether code is properly structured or it follows the coding guidelines, or there is no uninitialized variables, those kind of things, and formatting is proper, and very basic security check also, some static analysis, small quick test, those kind of things it will be doing during pre-commit. And before you push it to pre-commit, means after that, if everything is fine, then commit will happen. It will be committed to a local repo. But if it fails, you have to fix those issues. If it says that you have not you have not formatted your code correctly, you have to fix that, and then you will commit. After that, you are going to push it to repo, main repo, and before that, what will happen? You will run pre-push hook. So it runs before a push, so it can run a unit test. So you can set it up as a DevOps. You will be setting up a pre-push hook and a pre-commit hook. A developer also can do that. Unit testing, security checks, block push if the test fails. If a test fails, you have to block push. So that bad code should not be pushed to the branch. So this run even if you push to a feature branch. And then after you push it, so it's there in the in your GitHub. After you push it, you have it in the GitHub. So then you can do CI/CD. It will run some test, like it will install dependency. It can do more link tests, more static analysis. It can have better paid tool, commercial tool, which you cannot run locally. So all these pre-hook things, it runs locally before push, before commit, right? Pre-commit, pre-push, it runs locally on your machine. But some license or something, some uh, check which you need to do on the server, because server has the license or it needs more power, memory and CPU, etc. You may not have that in your local machine. So what normally happens in the real project? Real project, generally before you commit, you run some lint. It's a basic format. It's a basic hygiene test. And before pre-push, it's some basic test, unit testing kind of stuff to prevent broken code getting into the remote repo. And once your code is pushed to remote repo, there will be CI/CD, push to feature branch and run CI pipeline. And then when you finally push it to main dev branch, it will be doing the full deploy, full pipeline build. So your code is standalone, maybe UI, but finally you need to run with along with other microservices, right? SMS microservice, that microservice that you cannot run in a local machine. And it has to be integrated and worked with all other components. There are maybe another 20 different microservices. So it has to talk with all these 20 different guys and run it, right? Like, give me the SMS, give me this, give me that payment information. So it has to interact with all other microservices. So that will be done in the final. And it will be deployed in the server and it will be running on these automated test cases. So QA team will also help, testing team will also help to develop those test cases. They will give it to DevOps team and DevOps team can integrate that. Or QA team can also take care of that. So a typical Python flow, like before push, you do pre-commit hook, clean the code, pre-push hook, run some PyTest. And after push, you run some more tools and clean up and check any security issues are there. Then finally, PR request is created, pull request, and it's merged to the main. So now we'll go to the pull request flow. Pull request flow. So developer is happy. Just develop the code feature is ready. Let's say that whatever user authentication he has implemented, it's complete, it's done. So now that feature branch he wants to merge with main branch. So he will push his code and then he will create a pull request. So we will go to here. You can see that some code is added here, committed here. So it was recently updated 18 minutes ago. So compare and pull request. Then you can, a developer will create a pull request. So it will create a pull request and then create a pull request. And then once the pull request is created, it will be pending for approval. Maybe his lead will approve it, review the code, and if everything is fine, he will approve it. And once the approval happened, then there will be one more button, merge. So then you can merge with the main branch. And once it's merged with the main branch, there will be again CI/CD will do the deployment of the whole maybe build the application, create a Docker image, deploy it, or do complete end-to-end testing. Yeah, and during creating the pull request, developer is working on this feature branch, and because he has taken out that main branch, he forked out from that main branch and created this feature branch sometime back. And in between, that main branch also moved. Some few other guys also committed some changes and merged some changes. and that moved. Some additional features came in that. So what he has to do, has to rebase, so that you get a cleaner history. And then see any there is any conflict when you try to merge and there is some conflict. You resolve the conflict and then you continue rebase, continue. And if you are not able to do, you need help, then you abort the rebase. And if you are able to resolve the conflict, or you think that other developer also made some mistake, he has to change that, you will talk to him, you will abort it. And once you fix that, then you will again do rebase. And finally, you can force push it uh, required after the rebase. So never rebase shared branches. So if you're working alone on the particular feature branch, you can do rebase. But if multiple guys are working, it will be problematic. So rebase your only personal feature branch, right? So rebase means move my local feature user auth, like here this guy Rahul was working on user auth branch, so that it sits on top of the latest commit. So you have taken out from main and created a branch, and you are committing. So from that particular point of time, it committed. But there were some other commit happened. You want your commit to go on top of that. So that it's a clean linear history. It's easy to review. PR dip show only your change relative to the latest main, and you keep local topic commits logical. So you do the rebase. And what is the downside and safety rule? It will rewrite your history of your branch commit. So don't rebase public or shared commits. If it is your only, you have created the feature branch and you are the only person who is working on that feature branch, it's safe to do. But if multiple guys are working on that branch, it's better not to do. Another option is merge. Merge will preserve all the histories. Okay. And during merge also you may get conflict and you have to do the conflict resolution. And once the PR gets approved and merged, then you can delete the local branch. You can clean up the remote branch also. Git push origin minus delete feature, and it will delete it. So you won't be able to see from your branch here. You won't be able to see that branch once it's deleted because these are temporary. Your job is done. You have pushed your code. It's merged it. It's not required. Then there is a merge strategies. We need to understand what is merge, what is rebase. So merge basically preserves complete history with merge commit. So complete history will be preserved. Rebase will rewrite history to be linear. Okay. So when to use what? Rebase is personal feature branch for cleaner history. If it is a personal feature branch, no one else is committing, only you are committing. So you want a cleaner history, you can do that. Integrating uh, completed features to into main. That time you can do merge. Never rebase public shared branch. Now let's discuss about interactive rebase cleanup commits. So let's say Rahul is building a payment gateway integration. So Rahul is working on the feature branch, feature/payment. So while working, he created some commit, like he's fixing some bug, committed this bug, or committed this calculation issue, committed this XYZ issue, committed this memory issue, committed this. So many commits are there. It doesn't look clean actually because as and when he's fixing, he post like he committed 10, 15 commits, and it doesn't look clean. So finally he wants to when he wants to raise a peer, he he wants one clean commit. Basically, he was working on a payment bug. So he will say that payment like multiple payment or maybe some payment feature, payment XYZ feature was not working. So completed that payment XYZ feature. So no need to say that a calculation fix, this fix, because those are internal things. So you will basically clean up. I mean, whatever log you have, you will clean up that. So you will remove all these three and put nice uh, comment message like this: add payment gateway integration. So what he will do last three he wants to modify. So it's git rebase minus I head three. So last till the head till the three, so that last three comments you can interactively uh, modify. Take the last three comments and let me clean them. So Git will open an editor. It will look like this. Each line has a commit, and then keep the first commit as the main commit, rename it, and merge the other two into with the fixer. So we will add the fixer. Okay. Pick this one, first one, and these two fixer. Keep the commit. Pick is the keep the commit, and this is a fixer. So we will add this. So this will be like only this will be kept. The first one, pick. All three become one commit. So this is like rebase interactively. So because peer reviewers don't want to see all these work in progress comment, typo comments, there may be some typing mistake, spelling mistake, incomplete word. Because peer reviewer don't want to see that. You are completing. Okay, I have completed partially. Next day you completed again. You say I have completed some more activity. So don't that kind of logs they don't want to see. So for peer reviewers, they want to clean one single meaningful commit. Now we'll discuss about the cherry pick. So what is cherry pick? Let's say some critical payment issue happened in the production and you have to fix within 1 or 2 hours. So developer will switch to main, will add some fix in the payment.py file, let's say, and they will commit the message, commit the code and push it to origin. So once it's done, DevOps team will pick up this particular commit. This is called cherry pick. So maybe in this branch, so many other comments also happened, some other features, etc. But they don't want those things. They want only this particular payment related issue because this is very immediate, urgent. So they will do cherry pick. So they will say, switch release to this. This release was done to production and cherry pick this particular commit and then add backend payment PY, cherry pick continue and push the changes to the production branch. And then tag for backtracking. Then you have to create a tag also. Hotfix payment retry timeout. So use cases for cherry pick will be hotfixes to production, backputting features to old release, applying specific commits between branches. Next one, we'll discuss about stash, saving work in progress. So a developer is working and he's working on his feature branch and maybe he has not committed. He's working locally. A lot of files got changed. In between, he got a message that there is some issue in the production he has to fix. So he has to switch to the release branch. And now what he will do, he has to stash his work. So whatever temporary work that he will stash it somewhere, fix that issue, again unstash that. Right? So that is the stashing, mid-work interruption. So git stash push, save the work temporarily, and then switch to main and do the whatever fixing. Then again stash pop, restore the stash pop. So that is the stash. Then undoing changes, suppose like accidentally you added something to the staging area and you don't want that. You think, no, I don't want to stage that because it's a production secret. I staged it by mistake. So I have to, if I want to unstage it, I can do restore. By mistake, I did the add on this file. I can unstage using this restore. So this is also another question in interview you may face. Then discard working directory changes. Made changes to file but want to discard. So you can do restore. Remove cached file, already committed file. So you can do git rm cached node modules and then you can put them into git ignore so that it won't be committed again. Then git commit -n, commit the changes. Undo the last commit, you can do reset. Made a commit too early, you committed, now you realize, no, I don't want to commit. So you can do reset. Undo the last commit. Hard means it's a discard the changes permanently. There is a soft commit, hard commit. You committed, but you want to modify the message. You want to amend it. So you have this amend -n, amend the last commit. Then we have scenarios untracked file. So there are certain files which are not tagged by the Git, for example, temporary debug log files or build output, scratch files, Python cache file. We don't want to commit them. We don't want those files to be in your directory. We want to clean them up. So you can do git clean minus n, git clean minus n. Then we will come to tags and release management. Tag is basically like when you want to release it, it's a snapshot of the code. You have the main branch, and from main branch, particular point of time, you decided that you are going to release it. So development team tested, testing team also tested, and it's working fine. So you will tag it, and then release it. So we will create a tag. So this is create annotated tag, recommended for release. Then push it to remote. The lightweight tag is like this, lightweight tag, and annotated tag is uh, provide some more information. You can also do sign tag for security critical release. And there are different commands. You can list all the tags. What are the tags are there in the repo? You can show the tag details. Git show version 3.4.0. Then CI/CD pipeline triggers on the tag that you can do in the GitHub workflow. So this you won't cover here. Delete tags will be covering in the CI/CD phase. Delete tag, then delete remote tag, git push origin minus delete. Check out specific release. You can check out specific release. Reflog is for disaster recovery. So accidentally you did some hard reset, uh, like for last four commit lost. So you want to recover them. So you can recover using reflog. So you'll be able to view all the head movement, and based on that you can recover the last four commits. Conflict resolution is when you're trying to merge or that time conflict may happen. Trying to rebase, trying to merge, conflict may happen, and I have to do conflict resolution. How you do the conflict resolution? That is what discussed here. There are certain advanced Git commands like git blame, who changed what, line by line authorship. It will show in this payment.py file. This line who changed, another line who changed. So all these things you'll be able to see. Okay, because this line changed by Rahul, so because of that problem is happening. So Rahul should be like held accountable, right? This is a kind of git blame. Git bisect, you identify where the issue is happening. So release 10 was working fine, release 30 it was not working. So bisect in between git 20 you will test. If it is not happening, then maybe 20, 30 in between 25, release 25 will test. So that is the bisect part. I've discussed all these details in my YouTube video. You can check that out. I think they are the most important concepts covered. Recovery optimization. Yeah, shallow clone. So if your repository is huge and if you try to clone, it will take a lot of time. You don't want all the history. So you can do shallow clone, only just latest one. So you can do depth one. But if you need more history, you can use depth 100 or depth 500 or whatever. But uh, this will be like a faster if it is a huge repo and there are like a lot of history, maybe 5-year-old repo. Then many times you can do shallow clone. But problem is you won't be able to see the full history. Optimize the repository size. These are like a performance related issue. Clean up remote branches. You can do some pruning up. Git hook automation will be like in the CI/CD, pre-hook automation, pre-push hook example. So mostly this, and then we have here a workflow summary, real world workflow summary, where what developer do in the morning, then during the work, during then they create the peer, after peer is merged, and what DevOps guys do. So all these are there, some critical rules, and finally a cheat sheet. So that's it. That's it for today.